Welcome. My name is Victor Chokai. I am the CTO at Plastenergo Limited. In the next few minutes, I will explain how the prototype works, which was built by Plastenergo for the thermal processing of PVC-containing mixed plastic waste to produce alternative energy sources. In the world, there was no method for processing PVC-containing mixed plastic waste until our invention. Our patented process uses a two-stage degradation to chemically recycle plastic waste, the output products of which are diesel oil, petrol and hydrocarbon gases, carbon black, hydrochloric acid and other useful chemicals. Our equipment is therefore truly remarkable in that it does not minimize or eliminate PVC, unlike standard thermal degradation processes. The entire technology is controlled from the control cabinet you can see behind me. Why is it relevant? Because this means that even two persons can do the job from in-feed to handling the products. In the design of the process equipment, the different units are built into a standard container frame. This means that the devices are built into such container units and connected inside the container. The equipment itself starts with a feeding pulley that transports the pre-shredded plastic waste to the upper reactor. The upper reactor performs the preliminary splitting. This is important because the novelty of the entire technology lies in the fact that this reactor only removes the hydrochloric acid gas from the PVC-contaminated waste. At the operating temperature of the reactor, between 250 and 300 degrees Celsius, the resulting hydrochloric acid gas is removed and absorbed in water. This procedure generates a hydrochloric acid solution that can be used for industrial purposes after filtering. Why is this important? Because if we remove the chlorine from PVC in the first reactor, then we can prevent the generation of polyhalogenated hydrocarbons or even dioxin through the recombination of active radicals generating in the bottom reactor. This solves all the problems that have so far meant an obstacle to thermal PVC processing. The upper reactor does the dehalogenation and the intermediate mass generated here gets to the bottom reactor. This is where chain splitting of the polymer chains takes place and they fall apart to shorter hydrocarbon chains at a temperature between 500 and 600 degrees Celsius. This results in a gas-steam mixture which is separated in a condensing unit. The dehalogenation of the plastic mix takes place in the PVC reactor next to me. This means that the hydrogen chloride gas generated in this reactor from either clean PVC or PVC-contaminated plastics gets into a pipeline in a dry form, and, through this pipeline, it gets to the double absorbing system. The plastic paste, preheated and dehalogenated in the PVC reactor, is transferred to the bottom reactor where various hydrocarbon gas steam mixtures are generated from it at a higher temperature, between 500 and 600 degrees Celsius. These gas steam mixtures are fed into the inline condensing units shown here. They both cool the resulting vapor gas stream and separate them by boiling point. It is our proprietary system that allows for the production of different hydrocarbon mixtures by using the different cooling capacities of the condensing units. The first condenser condenses the heavy oil. After separation of the heavy oil, the gas-vapor mixture is transferred to a column with a double condensing unit. This column separates two different fractions, fuel oil and diesel oil. The third unit has the highest cooling capacity. This unit condenses petrol and light derivatives. It is necessary because the output gas flow is useful. The calorific value of the gas we produce is high enough to provide the heat needed for the upper and lower reactors by burning this gas after it has been fed back into our system. The condensation units are arranged in series. Consequently, condensates are constantly present in the different pipelines and allow sampling in order to extract products from them. Depending on their quality, these hydrocarbons can be used as engine fuels in petrol or diesel aggregators for power generation, although the oil derivatives we produce can be analyzed so that we can guarantee their quality. The important thing for the user is that these oil derivatives can be used to produce energy in the generator. We will see that soon. Although this petroleum generator is much more powerful than the power consumption of this 500W bulb, it still demonstrates the operation very well. The oil derivatives so produced can be transformed into electricity in such generators.